For decades, nuclear energy seemed to be in decline. And after major accidents like Chernobyl and Fukushima, many countries slowed down or even phased out nuclear program. Germany, for example, made a clear decision to exit nuclear energy entirely. But something has changed in recently years. Nuclear energy is no longer disappearing. In fact, it is quietly returning to the center of global energy discussion. This shift is not driven by ideology, it is driven by structural pressure. The first pressure is energy security. The 2022 energy crisis exposed how vulnerable energy systems can be when they rely heavily on external suppliers. The countries began to realize that energy independence is not just an economic issue, but a strategic one. The second pressure is decarbonization as the government push forward net zero targets. Fossil fuels face increasing constraints. At the same time, renewables, while essential, are not sufficient on their own. They are intermittent. They depend on weather and they require backup system. This third pressure is from rising electricity demand. Electric vehicles are expanding rapidly. Industries are electrifying, and data center, especially those supporting AI, are consuming unprecedented amount of power. According to projection from the International Energy Agency, the global electricity demand is expected to grow significant over the next decade. Some estimates suggest that the data center alone can become one of the fastest growing sources of electricity consumption. This creates fundamental challenges. The world needs more electricity, but not just more. It needs electricity that is stable, scalable, and low carbon. When we compare different energy sources under these constraints, a pattern emerges. Oil is still dominant in transportation. Natural gas plays a flexible transitional role. Renewables drive structural change. But nuclear energy occupies a unique position. It provides a large scale, continuous, low carbon electricity. It is one of the few energy sources capable of supporting the base load of modern economies. This is why many countries are rethinking nuclear. China is rapidly expanding its nuclear energy. France is reinforcing its long-term nuclear strategy. The United Kingdom is investing in nuclear projects. The United States is supporting next-generation technology, including small modular reactor or SMR. SMR representing an important shift. Traditional nuclear plants are large, expensive, and time-consuming to build. SMR aim to reduce cost and complexity through modular design and standardized production. If successful, they could change the economic of nuclear energy and make it more scalable. However, nuclear energy still face real constraints: high upfront cost, long construction timelines, regulatory complexity, and long-term waste management. These challenges mean that nuclear will not replace all other energy sources, but it doesn't need to. Because the role of nuclear is not to dominate the system, it is to stabilize it. From a system perspective, the future of energy is likely to hybrid fossil fuel, renewables, and nuclear energy will coexist, and each serving different functions. And within that system, nuclear energy may play the role of a structural anchor. If we step back and look at the full picture, a pattern become clear. Energy transition is not only about innovation, they're also about constraints. The world is not just because choosing new energy sources, it is responding to physical limits of stability, scalability, and reliability. And in that context, nuclear energy is not coming back because it is perfect. It is coming back because it is solves problems that no other energy source can fully solve. In that end, the most important question is not which energy is the most popular, but rather which energy can sustain the system when everything else is under pressure. That is where nuclear energy and uranium quietly becomes indispensable.